Next up, are you ready to hear about which vault? Are you ready, sir?
5 minutes break or?
Oh no, we're moving on. We've taken up our break time.
Okay, good.
Thanks so much.
Thanks for having me on Indiana. I come from the Netherlands, from Amsterdam, so it was quite a journey for me, but I'm used to it. So this doesn't work. I'll do it with the arrows. This is about me, just an overview, but you are not coming from me. I started in IT 20 plus years ago before I did something in pharmacology and hospitals and everything like that. I live in Amsterdam in the Netherlands, in Europe, and yeah, these are my contact details. And this one, a little bit commercial. I'm writing a book about CI/CD patterns, along with 3 other authors. It's coming up. Well, it says autumn, but it's gonna be late autumn, so maybe somewhere in beginning winter. But we're finalizing the book at the moment, which takes a lot of work, extra work, which we didn't expect. So anyway, what I would like to talk about in these 20 minutes of fame, I would like to talk a little bit about, well, not about security. Security was already mentioned in this slide. It's complex. It spans a lot of issues, a lot of topics, and when you look at it, I got the inspiration of this talk about a project I did for the Dutch government. As you might know, situations in the world has changed, and years and years after the Cold War, the Dutch government didn't invest anything in the Dutch defense, militaries. And last few years, they are well, investing more and more also to make a good defense system, but also get the IT for it ready. So the entire computer infrastructure, which people use either in the field or at a base camp or anything like that, it can be important to look at. I'm now working as an enterprise architect. Am I not? So at the moment, I work for the Dutch government as an enterprise architect, and I'm part of the CTO office. And okay, yeah, was there or there. Oh, right. So sorry, I work for the Dutch government as an enterprise architect. At the moment, I'm part of the CTO office, and like I said, security is complex, but it's also a very important topic, also for board members and board directors. And if I look at our CTO and CEO and everything like that, they all think security is a business risk, because your data, you don't want to compromise your data. You don't want to not follow regulatory stuff. You also don't want to have any reputation damage. So they think it's important, and they think you have to invest in it, which is very good. If you look at the project which I did for the Dutch government, for the Dutch Ministry of Defense, it was building an entire new infrastructure for doing anything which is maybe a legacy, but also cloud native. Cloud native was, in fact, the way to go. And it was built up a data center, an entire new data center with all the new equipment around that for AI and all those kinds of things, with GPU and processors and high-end computing and all those kinds of things, and also a container platform which was ready to develop new applications, microservices, all kinds of that for the Dutch Ministry of Defense. So when we started to build it, we also tried to identify all the risks which you have with it, because a container platform like Kubernetes is not very strong in security. So you have to switch over to other solutions around that. So if you look at the risks of a container platform and also the entire flow of development until releasing to production, there are certain kinds of risks to identify. First, you have the container image risks. You have your registry where your containers are stored. There are risks over there. You have your orchestrator risks, so access to who gets access to any administration work. And also, of course, the computing, the nodes or the host servers, whatever you call it, operating system risks. So if you look at some of these risks, if you look at like images, which are images from containers, there can be missing updates. You have to fix them, configuration defects, untrusted images from external repositories, which developers pull in and try to work on their own private laptop or their own private server, and you don't see anything around what's happening over there. And also, of course, plain text package passwords within files. Looking at the registry itself, where the containers are, you can have stale images because they're at rest at this registry, so you can miss updates, and they can be vulnerable for any kind of issue around that. It can consist of insecure connections, insufficient authentication, workloads might be mixed around that, and you can also think of a kill chain attack with these vulnerabilities in these images. So this is an example of such a kill chain attack out of registry, where a cryptominer malware was in a package in an image, which was pulled in and without knowing all kinds of infection, infiltration, lateral movement, reconnaissance, all those stages which you have when you have a kill chain, and they could run all kinds of execution commands for this cryptominer malware. Of course, container landscape risks, orchestrator risks, so administrator access need to be addressed. Mixing workloads, sensitivity levels. So if you have kind of workloads for your finance department and for your HR department, they can be mixed, but you have to consider good isolation of these kinds of things. So one of the things we had to figure out is how to do secret management. Let me tell you, we built this platform, and I was responsible as a solution architect for a specific kind of solution building block, which was a container platform. And one of the things which wasn't thought of properly was secrets management. So if you look at secrets themselves, what are they? Well, it's a combination of a lot of things, but when you have secrets, when you talk about secrets, when you talk about well, just plain passwords, but also API keys, certificates, keys for your SSH access to servers, all those kinds of things. Well, you might know if you are at home at a typical household, your keys, you throw it somewhere in a corner, you don't know where they are. So your wife or your kids do it the same. You don't have anything, you always have to search for them. So one of the things which is the risks within this kind of things is a secret sprawl. So secrets are coming from everywhere, used everywhere, but we don't have any control about it. It's not centralized, and you want to have more control and monitoring around that. So you have to manage it to prevent secret sprawl, but also other risks around that. So these are the common types of secrets: API keys, passwords, SSH keys, certificates for web access or anything like that. When you look at the container native landscape, there are certain kind of types of secrets in Kubernetes, the opaque ones, the default ones which Kubernetes used with a base encode option. You have your service accounts tokens, your container registry secrets, some basic authentication, HTTP, and of course the TLS SSL certificates, and bootstrap tokens for when you use OpenShift to kickstart your deployment. So use of secrets, well, they can be different use cases for your secrets. So you can do an image pull from a registry, you need a secret for. Allow your kubelets to pull images, registrations of your nodes, environment variables for your containers, and the form of secrets which are in Kubernetes are usually maybe through a CLI with an API, as a YAML manifest, or with a tool like Customize. And they're exposed like environment variables mounted as a volume in a pod. So this is a typical flow of such secret in Kubernetes, where you can see that the secrets are temporarily stored in a file system, in memory, and the pod is using it, which is mapped by a application to the pod, and the application can use the secrets to access a system. So some of the challenges around secrets are store your secrets safely, secure, in an encrypted way, access controls and auditing and everything around that to be aware of what's happening to your secrets. But also this distribution of your secrets is very important. So know which teams or services are using the secrets and for what purpose. Another important thing is to rotate your secrets, because you don't want to have you have a policy maybe within your organization to rotate or update frequently your secrets or your passwords, but you also don't want to have compromise it and reduce the risks of it. And of course, preventing unauthorized access. So you can build in a typical secret management tool to build in something like an RBAC or ABAC mechanism to access your secrets only if you are able to, or if you are if you're allowed to be accessed. Well, risks, they can be data breaches or compromise of your system, disruption of your services, and of course, tampering with your secrets to use them for any other purpose. All right, I just want to switch to this use case which I had. This is you want to also, because secrets are not just human. I have already 10 minutes. So secrets are not only for humans, because you also have your automated pipelines, your CI/CD pipelines. You want to build them in. So you have your version control, where a developer pushes its code within a version control system. It triggers a build to the CI/CD server, and the CI/CD server fetches the secrets from a secret management system, runs some tests, and returns the secrets again to the secret management system, build a package and testing, and send the artifacts to the continuous deployment for releasing, deployment to staging, and finally release to production. So there are a few secret management tools which I'd like to discuss a little bit, not too much, not because one is better than the other, but just because of the use case which I already mentioned at the Dutch Ministry of Defense. So you have HashiCorp Vault, you have CyberArk Conjur, and Kubernetes Secrets, which we investigated, and some more from cloud. They are not very important for this presentation. So this DevOps solution project was about building an infrastructure, private cloud infrastructure for the Dutch Ministry of Defense, air-gapped, so disconnected also, so that was an extra challenge for that. Using all kinds of cloud-native technologies, and also integrate identity and access management, secure secret management, build a container platform and capabilities for end users or developers or teams to build their applications on. So the first secret management tool we investigated was CyberArk Conjur. So CyberArk itself, it's a solution which has a lot of in it, a lot of different solutions in it. But we were looking for the centralized secret management. And why? Because the security was another security building block, was another solution building block, and we had to use that solution within our container platform. However, during during the project or program, we ended up that the security building block wasn't ready yet for this. So they had built a security system, but they didn't have any secret management in it. They were building it, but they were not ready for that. So as we released our container platform iteratively, sorry for that, we started building it as a MVP, of course, minimum configuration, and moving on to base and to full and all those kinds of stages. So we thought this is not a good thing for us. We can't go on. We have to wait for this because they're not ready for it. Well, as a good secret management solution, CyberArk has some kind of a centralized secret management for your storing your secrets on a central location, role-based access control, which what we wanted, audit trail compliance, monitoring your audits for the security officers, automation of your secrets, automated rotation of your secrets, and integration with all kinds of other tools and solutions which we are using. So this is a little bit about the setup we had thought of. At your right, you see a container platform solution building block, which we might call it. So you have here we built it in OpenShift. It was an OpenShift master node and an OpenShift worker node in an OpenShift cluster, where we had at the left the Conjur server with a Conjur vault, and the Conjur solution had a Conjur follower, which was a different pod, was not a sidecar, but a pod which was connected and with the Conjur vault, and which pulled the secrets out of it for the application. Anyhow, this wasn't the really solution which were using at our MVP stage. Finally, we should switch to this because the PAM integration and all those kinds of things, so privilege access management and identity and access management, were all a set of solutions which we had to use. So this is a little bit about how Conjur works. You have the Conjur database to store your secrets. You have a policy engine to configure authentications for your applications, for providing access to secrets, for providing to your applications. And you have an audit database to monitor all kinds of events and actions around login and pulling secrets and everything like that. The next thing we considered was HashiCorp Vault. Thing was we were building a IT operations data pipeline, which was built for monitoring, centralized logging solution for elastic logging and all those kinds of things, advanced search and everything like that, to be able to for developers and also for operations to gather these log files and to do with it like what they want in an automated way, maybe. Anyway, when you look at HashiCorp itself, it also provides all the benefits from a centralized secret management tool, encryption as a service like audit logging, leasing, renewal, just like CyberArk also has. Dynamic secrets was very important. So dynamic rotation, so you don't need to do it manually, which like kubectl, you have to do it manual. And this was a little bit the solution we had thought of. At your right, you can see the IT ODP solution, which was the operation data pipeline, and they had a messaging API to collect all the logs from all the platforms and systems and to centralize it, and also used within the solution HashiCorp Vault secret to store all the secrets and to publish them as well. Anyhow, because we were a commercial company for doing this for the Ministry of Defense, it was licensed only for this particular solution. So we couldn't use this one too, unfortunately. So we skipped this one, and well, this is a little bit about how HashiCorp Vault works. A little bit similar to what Conjure has. For our MVP and also for our base, in a time of line, we had to switch over to sealed secrets from Kubernetes, which is a pretty good solution if you depends on your requirements in your use case, of course. But for our MVP, for our base, it was pretty a good solution to use anyway to go further with our releases. For Kubernetes sealed secrets, it's a solution which you have with an encryption key, using a public key and a private key, which you can store in your code repository. You have automated lifecycle management, which can be done by Kubernetes itself. You have an operator which you deploy in your Kubernetes cluster. So this is a little bit about how it works. You have your API, you have your secrets in here. It's just a typical default secrets, which, oh, my time is up. Anyway, we use Kubernetes sealed secrets for that, and well, we moved along in time, and at the end, we could use the final CyberArk solution. But Kubernetes sealed secrets is typically good for in-between solutions, or if you have a small environment, not an enterprise scale environment. Okay, thank you very much for your attention. I hope you have a great rest of the day and the rest of the conference, and see you around somewhere.
Great.